say 4 times 2. I could represent 4 with lines or sticks or whatever, and then cross that with 2 more. And if I count up those intersections, there are 8 in there. So what this picture really represents is the multiplication fact, 4 times 2 equals 8. Except I don't have to remember it, it's right there in front of me. When we move this into the context of a larger problem, you can see where it really helps if you don't know your facts. So I'll represent 21 with 2 sticks for the tens and 1 for the ones, and then 13 with 1 and then 3. You'll notice that this really isn't much different from the way we write things in numerals. That 2 and 21, for example, isn't really a 2, it's a 20. And those 2 lines on the left aren't really 2 lines, they're 2 lines of 10 each. We can color code them and make it a little bit simpler to keep track of. So there are the tens and the ones. Well, let's see how this stacks up against our kind of normal multiplication. If I start off on the right with 1 intersecting 1, there are 3 of those intersections, which corresponds to 1 times 3, and I leave it in the ones place. On the left, if I count those 2 intersections, that's really 2 tens and 1 10. So that 2 is not really a 2, it's a 200. 20 times 10. And then in the middle, I have red intersecting green. So up here, that's 2 tens times 3 ones, which gives me 60. And then down here I have 1 10 and 1 1, which gives me just, well, 10. So that's a total of 7 tens. And you can see that that matches up with our multiplication on the right. Some of you may recognize that as the partial products algorithm you probably learned in school at some point. If we want a little bit trickier problem, one that requires regrouping, we can try 123 times 321. There's 3 hundreds, 2 tens, and 1 1. And let's color code them again. Hundreds, tens, ones. Well, if I look out here where my ones intersect my ones, I wind up with 3 intersections. And so I leave that 3 in the ones place. Next up, I have yellow intersecting green, which means I'm getting tens and ones. So out of that, I'm going to get tens. If I count up those intersections, there are 8. So 8 goes in the tens place. On the left, I get 3 intersections, but that's hundreds and hundreds, which gives me 10,000s. So 3 goes in the 10,000s place. Now I have red and yellow, so that's hundreds and tens, which is going to give me thousands. If you count them up, there are 8 of those. And in the middle, I either have red intersecting green, which is ones and hundreds, or I have yellow intersecting yellow, which is tens and tens. Either way, that's the hundreds place. And if you count them up, you wind up with 14 hundreds. Now, just like in regular multiplication, that's a problem. I can't have 14 in the hundreds place, so that really is 1,400. So I take that 1 and I bump it over to the thousands place, and I wind up with 39,483, which happens to be the correct